beginning. I really, really, really would like it and love it if you could unmute yourself and talk, but I know no one likes to do that, so I guess that's up to you. So, do you have any specific, particular questions that you would like to go over? Or I can just start from the beginning. Somebody give me direction. Uh-oh. Ooh, okay.
You can just start from the beginning.
Start from the beginning? Okay. As they say in The Sound of Music, you can just start when you. How'd that go? When you begin with A, B, C. Anyway, Sound of Music. All right, here we go. Franny's mom is making her donate clothes to Goodwill each month. She gives the same amount each month. All right, Herlin, hey, can you, there we go. I was going to say, I heard some background noise. Use the table to answer the question. So, number of months. This is number of months, okay? So, after 2 months have passed, she owns 180 clothes. After 4 months have passed, she owns 160. After 6, 140, and then 8. So, slope, remember, is rise over run, several ways to do this, or change in y over the change in x, or y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, okay? And as you look at these, your independent is almost always the variable that deals with time. So months just happen. They go on. They don't care about anything else. So yes, this is your x. This is your y. So your slope, you need to look at any of these x, y values. And these are almost like individual ordered pairs. That's an x on top and a y on the bottom. So you are going from, let's say I'm looking at these two right here, 160 minus 140, all divided by 4 minus 6. Okay, so 160 minus 140 is 20, and 4 minus 6 is negative 2. That means my slope here is negative 10. Okay, what does this mean in the real world? Does anybody want to take a quick guess? For this problem, what does it mean for this problem? Nope. Okay, well, it means that Franny's mom, I guess we could say Franny is donating, and that donating gives the negative connotation, so that's why it's a negative 10, donating 10 pieces of clothing each month. 10 pieces of clothing each month. Okay? And because it is slope, you do want to talk about both of them. The amount of time that's gone by being the 1 month, and that it's donating those articles of clothing. Okay? The y-intercept. The y-intercept. So usually the y-intercept, if I think of a graph like this, your y-intercept is going to be somewhere up here, okay? And that is where x is equal to 0, because here we have 0, we have 2, 4, 6, 8. So remember, the y-intercept always has x is equal to 0 and the y is some number. So if x is equal to 0, which I don't even have up here in this table, that 0 would be right there. Okay, so if I'm going backward in time, and this is 1 month, okay, I would need to say that in 1 month, she owned 190 pieces of clothing. So that means at 0, if I add 10 more, that would be 200. So the y-intercept here is 200, or you could say it as 0, 200. Either way. So what does this mean? This means before Franny donated any clothes, she had 200 pieces of clothing. Okay? Any questions about that? Okay, so the x-intercept. The x-intercept is going to be on the x-axis, and I'm looking for some number for the x value, and I know my y amount is going to be 0. So the y's are getting smaller and smaller and smaller, okay? So I'm going to erase this for just a second so we can extend this out. So if I kept continuing on here, 140, 120, and then 20 more would be 100, at 10, 80, 60, 40, 20, and 0. And that's what I want. I want that to be a 0. So this would be 12, 14, 16, 18, and 20. So that means the x-intercept is at 20 or 20, 0. And what does that mean in the context of our problem? That means if she continues to donate 10 pieces of clothes to Goodwill each month and she doesn't get any other additional clothes, that means that Franny will have no clothes at all after 20. This is in months, yes, months. Okay, which doesn't make a whole lot of sense in real life, but that's what it is. That's what it means for this problem. Okay, so finally it says let's write an equation for this situation. Remember, these are linear functions, and that is in the form of y equals mx plus b. Does anyone want to give me an equation or offer up one? I do have a bit of a cold. No? Ooh. Y equals negative 10x plus 200. That is correct. Yes, so putting it all together, y equals, here is m. Remember, your slope is m. So that is negative 10x. And then plus b. B is your y-intercept, which is 200. And remember, the y-intercept is where we started. Okay? So that is it. Very nice, Janetta. Thank you. Any questions about that one? All right, let's go to number 2. I'm just checking my time. Oh, I have until 9. Perfect. 18 more minutes. This table shows the costs of different Colts tickets packages. Does the table show a constant rate of change? In other words, is this linear? Janetta says no. Okay. Well, let's see. Number of tickets, 2. Cost, $109. Let's see. So, 4, if I got 4 tickets, that would seem to be 109, come on, times 2, which would be 218. So, if it was linear, it would be 109, 218, and for 10, you would think it would be 5 times that, 109 times 5, which would be 545. So, yeah, just looking at a couple of them, I think we can definitely say no. If you answered yes to part A, what is the rate of change? If you answered no, why? Explain why it is not constant. So, why is it not constant? Well, you can say the prices do not match up with a consistent slope, or I should say change, rate of change. That's probably better. Slope is more when you're graphing. The prices do not match up with a consistent rate of change. Consistent being the key word there. I was just going to put increase. They're not a consistent increase. Okay? Questions on that? All right, let's take a look at the next page. All right. Derek opened a new bank account. Explain what each of the following equations would tell us about the amount of money in his account over time. Over time. Okay? So again, we're looking at y equals mx plus b. Y equals mx plus b, where b is your y-intercept. And because it's your y-intercept, that's where x is equal to 0. That's usually your beginning amount, right? And the slope is going to be the change, the consistent change of the account. All right? Does anybody want to offer up anything? Unmute yourself. It's probably easier if you just unmute. For A or B? How much, or did he have anything in the account to begin with? Oh, you're all so shy. Started with $1,400 in the bank, then took out $300 every month. Perfect. Yes. So, Derek, you could say started or opened the account. Anything that indicates an initial amount. Ooh, lovely pen. Derek opened the bank account with $1,400. That's your y-intercept. Okay. And then over time. Now, the time, they do not specify time, so you could say it could be years, could be minutes, it could be days, it could be months. I think for banking, we would probably be thinking months, but if he gave me a different amount of time, that would be fine. Okay. Then he removed $300 each month for, I don't know, you don't really have to say what it's for, but he removed or took out $300 each month for, I don't know, I'll say groceries, but you wouldn't even have to really say that. But that just implies to me that you realize he is taking that out. If I can move this down, over, maybe not. I can, I suppose, minimize. Okay. And now it's probably gone forever. Ah. Okay. All right. So then y equals 75x. What is my y-intercept here? What is my y-intercept? Now, it's still the same Derek, but this is a new equation. Okay, new equation. So, it's a new monetary situation. Morning, Jaden. We are working on the review packet. So, added 75 each month. Yes, he did that. How much did he start with? He actually didn't have anything to put in the account initially. Okay, so I don't know if you can really open an account and not have anything. But basically, your y-intercept is 0. Okay, so I guess you would say Derek initially had no money, but he added $75 each month from his part-time job. And again, you don't even have to talk about the part-time job. Okay? All right. There's number 3. Any questions about that? All right. And again, if you really want to see one, feel free to stop me. Okay, number 4. State the independent and dependent variables for the following situations. So remember, independent means it can stand on its own. Dependent means it's dependent upon the independent variable. So Jasmine started with 60 TikTok followers and gains 15 new followers each week. Each week. So independent often has to deal and do with time. So my independent over here, I'm going to say is, oh my gosh, it's so irritating. The number of weeks that go by. And it's saying she's gaining 15 new followers. So the dependent variable would be total number of followers on TikTok. And sometimes people forget all those labels, but it's really important for the graph to make sure we understand what it is we're talking about and that we're on the same page. Okay? So, letter B, Audrey forgot to return her school Chromebook. She is charged $10 for every day it is late. So again, the time here, that's the independent. Time just keeps on going. It doesn't matter what happens. All right. So this is number of days late. And the dependent is going to be the total amount charged. Total amount charged. Now that's kind of an interesting one. It kind of has to do with the homework where we're talking about depth. Depth indicates a negative. You say a depth of 15. That's a very interesting one. So that one, total amount charge. If we talk about a charge is a negative amount, but the charge is also that positive. Charge indicates a negative. Anyway, I was thinking more about the graph, but that is what the independent and dependent variables would be. Okay? All right, moving on. Number 5. Got 6 minutes. Which of the following situation best fits the graph shown? All right, so first of all, what do we notice? What do we notice? It's negative, right? Negative slope. So it's decreasing. Negative slope. Something's going down. Peyton has 20 books. I missed what the first one said. Is it C? Let's see. Peyton has 20 books and buys 3. Well, if he was buying 3, that would be increasing. So I definitely don't think it's that. She has 60 flower pots and sells out in 3 months. Jim lives 60 miles away and arrives home in 20 minutes. So that could be a possibility. Jeff lives 20 miles away and drives home in 60 minutes. Nope, I don't think it's that. 60 miles away, arrives home in 20 minutes. So I'm going to say this is probably minutes. 6 and sells out in 3 months. Yeah, I don't think it is that. Yes, I would say it is C. Y-intercept is 60, so that tells you where you are starting with, and both of those started with 60, but sells out in 3 months. Nothing indicates 3 down here. If this was months, 3 months would be here. So that is not the correct one there. So letter C is the correct answer. Very good. All right. And number 6. Let me just look over here. It says continue? No. I'm surprised no one asked for the timer. Everyone's favorite. Terry loves Papa John's. He learned that a medium-sized pizza is perfect for him to eat for dinner. On Thursday, he ordered a medium 3-topping pizza for $13.75. The following Tuesday, he ordered a medium pizza with 7 toppings for $18.75. Identify the independent and dependent variables. Okay. All right. So, independent and dependent variables. What do you think we're talking about? It is not necessarily time. I'm going to say independent is going to be it's not number of pizzas, number of toppings. size of pizza? Well, they're both the same size. I don't think it's size. That's a good thing to do here, but I'm going to say independent, I think, because they're medium and we're talking about this, independent variable is not toppings. I think it is. I think it is number of toppings. Is it not? I'm gonna say number of. Let's see. It's got to be something like medium pizza with number of toppings. Because the number of toppings is going to be consistent, I hope. The dependent variable is going to be cost of the pizza. It's not, because with 3 toppings plus a medium pizza. Oh, okay. Well, let's see. So 3 toppings. Yeah, maybe we should do some math first. 375. Oh no, I'm running out of time. And then 1875 was with 7 toppings. So that means it was a difference of $5. So that means 4 toppings would be $5. So each topping could be how much? $1.25. So that would seem to say that a medium pizza is $10. I don't know. I think that works, doesn't it? 7 times $1.25. I know you guys need to get going. 1.25 times. Oh, come on, get back on. 1.25 times 7, 875. I think that works. So, cost of pizza. And so this is going to be y is equal to, that's your increase or change, $1.25 times however many toppings plus 10. Okay? All right. Oh, man, I lost everybody again. Okay. 1, 2, 3, 4, 5, 6, 7, 8. I think I got 8. All right, guys. So right now, I think, again, the plan, I haven't talked to Bieshki, but I think the plan is we will test on maybe Thursday. Not sure. Hopefully we'll be back together tomorrow. So please come in with your questions and we'll go from there. So thanks for being here, and hopefully I will see you tomorrow. Keep working on your homework too if you haven't gotten that finished. All right? Okay. Thanks. Bye-bye. Meeting compact view. I don't know what that is. So I got Sandra, Daniel, Ashley, Sakia, Emma, Kennedy, Bill, Elijah, Marvin, DJ. So absent, 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 absent. Savannah, Kamani, Sean,